Hello, I'm Mr. Howard. In this video we're going to do a review over the equations of linear functions and linear regression. This video is targeted for my pre-cal students, but anyone working with linear functions or linear regression can use this video for help. So the first thing we need to look at and review are the different forms of lines. So we have the standard or general form here, and different sources write it differently, but it's equivalent. Ax plus by equals c, or ax plus by plus c equals 0, where a, b, and c are a and b would be coefficients and c would be a constant, and then you have your x and your y variables here. Slope-intercept, you're probably most familiar with this, y equals mx plus b. On all of these forms, m is the slope, x1 comma y1, and x2 comma y2 are points on the line. A is the x-intercept and b is the y-intercept. So this is a very valuable form of a line because it gives you the slope and the y-intercept clearly in the equation. Next, point slope, y minus y1 equals m, the slope times the quantity x minus x1, again where y and x would be variables and your y1 and x1 would be the x and y coordinates of a point on that line, and your m is the slope. Another form that you may not be as familiar with is the intercept form, and that's x over a plus y over b equals 1, and again you have your x and y variables here, and then a would be your x-intercept and b would be your y-intercept. Vertical lines, those are in the form x equals a, where a is the x-intercept, where it crosses the x-axis. Horizontal line, y equals b, where b is the y-intercept. Okay, let's look at some examples here. We're going to look at a total of 9 examples, I think. So let's get started here. The first one says, find the equation of the line in slope-intercept form passing through the points 4, 3, and 1, -6. So they're giving us 2 points and they're asking for slope-intercept form here. So we need to end in this form right here. And we're going to use our slope formula, which I did not list, to find out what the slope is and go from there. Okay, so we have 2 points, so we're going to label. We always need to label x1 comma y1, x2 comma y2. Alright, that always helps us keep it straight what's what. Remember that the slope formula is m equals y2 minus y1 over x2 minus x1. Okay, so we're just going to fill this in. So that would be -6 minus 3, that's y2, that's y1, divided by x2, which in our case is 1, minus our x1, which in our case is 4. So that's equivalent to -6 minus 3 is -9, and 1 minus 4 is -3. -9 divided by -3 is +3. So our m is equal to 3 here. So our slope is 3. At this point you could plug it into point slope and use that form, but I'm going to show you another way that I find that when most students are shown this method, they prefer it. It requires less work in most cases, so I'm going to show you that. All we have to do is utilize my favorite form of a line, the slope-intercept, and we just plug in here. So we've got our m, and we've got a value for x, and we've got a value for y. We could use either point. I'm going to choose to use 4, 3. So we're going to substitute in 3 right here for m. We're going to substitute 3 in for y. Okay, I'm going to write our knowns here. Our m equals 3, and then we have the point 4, 3. Okay, and where this is x1, y1. Okay, so I'm substituting our y coordinate of 3 in here for y, and then I'm going to substitute 4 in for x right there. And then we are simply going to solve this for b. And once we have b and we already have m here, then we can just write the equation. Okay, so let's do that. So we would rewrite this as 3 equals 3 times our x value, which is 4, plus b. Okay, and we're solving for that b right there. Okay, so we get 3 equals 12 plus b. Subtract 12 from both sides. We get negative 9 equals b. And now we have it. So our equation and final answer is just y equals our slope 3 times x plus our b value, which is negative 9. So I need to erase that plus and make it minus 9. Adding a negative is the same thing as subtracting. So final answer, y equals 3x minus 9. Alright, let's move on to the next example. Okay, example 2 here. Find the equation of the line in slope-intercept form parallel to the line given by 3x plus 2y equals negative 1 and having a y-intercept of 5. So they want slope-intercept form, so we just need two things. We need slope and we need intercept. So we've got the y-intercept right here, already given to us. So now all we have to do is take this line, identify its slope, and we'll have it made because we have a parallel line here. Remember, we're parallel to this. So we find this line's slope, and that gives us our slope because remember, parallel lines have the same slope. Okay? Alright, so let's write this line, 3x plus 2y equals negative 1. All we have to do is isolate y. That'll get this line in slope-intercept, therefore revealing the slope to us. So subtract 3x from both sides, and that's going to give us 2y equals, I'm going to rearrange this, negative 3x minus 1, so that's in our normal form where our x term is listed before the constant. Okay, I'm going to divide by 2 here, divide everything by 2, and that gives us y equals negative 3 over 2x minus 1/2. Okay, we don't care anything about this minus 1/2 right here, this negative 1/2. We're only concerned with this part right here, our m, our slope, because we need that for the line that we need to write. So we have our slope is going to match this slope and be negative 3/2. We also already know our y-intercept, so that's going to make our line simply y equals negative 3/2 x plus 5. Okay, so we have answered that question. Okay, remember, parallel lines have the same slope, so we identified this line's slope as negative 3/2. Our line would also have the same slope, and they already gave us the y-intercept of our line right here. So here's our answer. Alright, let's move to the next example. Alright, example 3 says express y equals 3/4 x minus 7 in general form. Remember, the general form was ax plus by plus c, or it could be written as ax plus by equals c. Okay, so that's the form we want to go to. So right now we have y equals 3/4 x minus 7. And notice that in each of these forms that the number in front of a needs to be a whole number. The number in front of the number in front of x needs to be a whole number. The number in front of y needs to be a whole number, and then we need to have a whole number as our constant. So in order to do that, we need to get rid of this fraction right here. If we had a whole number as our slope already, we wouldn't have to worry about it, but since we don't, we need to just get rid of that fraction. So remember, anytime we want to get rid of a fraction, we just multiply each term in the equation by the denominator, the bottom number. So, and if I multiply this term by 4 in this case, I have to multiply this one and this one. So we're going to multiply that by 4, we're going to multiply that by 4, and we're going to multiply this by 4. Okay, that in turn cancels this out, leaving us with 4y over here. These 4's canceled, so we're left with 3x minus 28. Alright, and in the general form, we're going to use this one right here. We need the x term, the y term, and the constant all on the same side. So we want to move the 3x over, and we want to add the 28 over. Okay, so that's going to give us negative 3x plus 4y. Whoops, my fault there. Not equals. We want them all on the same side. plus 28 here. And that would all then be equal to 0. Okay, so this is our final answer. Negative 3x plus 4y plus 28 equals 0. I need to add the equals 0 up here, by the way. I forgot that in the beginning. Okay, so final answer right here. If we wanted to write it in this form, we also could do that, and we would have just left the negative 28 over here. So another way to write it would be negative 3x plus 4y equals negative 28. Okay, really either form is acceptable. Alright, let's move to the next example. Alright, so next we have example 4. It says express y equals 3/4 x minus 7 in intercept form. I've gone ahead and I went ahead and wrote the intercept form here. That's x over a plus y over b equals 1. Most students probably aren't as familiar with this form. It's not as widely used, but remember that the x and y would be variables in this case, and then the a is your x-intercept and the b is your y-intercept when you're done, and it's got to be set equal to 1 in order for this to be true. Okay, so we have the line y equals 3/4 x minus 7. So the first thing that we need to do to make this look like this is get the x and y terms on the same side. So I'm going to subtract this 3/4 x, and that would give us negative 3/4 x plus y equals negative 7. The next thing that I need to do is make, notice here, I need a 1 right there, so I've got to make that negative 7 equal to 1. So how can I make negative 7 equal to 1? Well, anything divided by itself is equal to 1, so I just divide that by negative 7. When I do that, I have to divide this by negative 7 and divide this by negative 7. Alright, when I'm done with that, I am going to get equals 1 over here, and I've got y over negative 7 here. Now this part is a little more difficult because we're dividing a fraction by a number, so let's just work on that off to the side. So really what I have here is negative 3/4 divided by negative 7, and then I can put that over 1 so that we have a fraction divided by a fraction, and we can work with that. And that's we have negative 3/4 divided by negative 7 over 1, and then x. Okay, so when we divide fractions, remember we just flip and multiply. So this is equivalent to negative 3/4 times 1 over negative 7 x. Okay, and that's equal to negative 3 over negative 28 x. Okay, so these two negatives will cancel out, and that just, to simplify that, that's 3 over 28x. Now the problem is we need x by itself in the numerator here. So to multiply by 3 over 28 like we're doing now is the same thing as dividing by its reciprocal. Okay, multiplying by a fraction is the same thing as dividing by its reciprocal. So when we're done here, this is equivalent to x over its reciprocal, 28 over 3. Okay, so this is how we need this to look. So we have x over 28 over 3. Okay, and now we have it in the correct form because our x-intercept would be 28 over 3, and our y-intercept would be negative 7 in this case. So I'm going to put a plus sign in between here, and we have it done. So there's our final answer. So the fraction part was a little tricky, but the rest of it was pretty straightforward. So this tells us that our x-intercept is 28 over 3, and our y-intercept is negative 7. Alright, so that's a little bit, that problem was a little bit more difficult because of the fractions. Alright, let's move on to example 5. Alright, now we have example 5. Example 5 is pretty simple. Find the equation of the line parallel to the line x equals 8 and passing through the point 5 comma negative 17. Alright, well, if we have the line x equals 8, remember that is a vertical line. Okay, anytime you have x equals a number, it's going to be a vertical line. So if we draw our coordinate plane here, we have line x equals 8 would be, for example, if this was right here was equal to 8, that would be x equals 8 right there. So in order to be parallel to a vertical line, our line also has to be a vertical line. So all we have to do is say that that is x equals the x coordinate that they gave us, x equals 5. Okay, that's all there is to that one. So x equals 5, let's say, would be, the scale's not very good, but right in here. So x equals 5, right there. Okay, so to be parallel to a vertical line, we also have to be a vertical line. And if they give you a point and ask you to write the equation of the vertical line through that point, it's just x equals the x coordinate that they give you. And that's all there is to it. Alright, let's move on to example 6. Alright, example 6 is a little bit more complicated. Find the equation of the line in point-slope form. So they want point-slope form here, which remember is y minus y1 equals m times x minus x1, where y1 and x1 are coordinates of a point, and x and y here are variables, and then m is the slope. Okay, so they want it passing through negative 1, 6, negative 1 comma 6, so that gives us a y1 and an x1 already, and then we want it to be perpendicular to the line that they give us here. So remember that perpendicular lines have opposite reciprocal slopes. Opposite reciprocal. So we have to take the slope that we find of this line, flip it, and change the sign. Opposite reciprocal means flip it, change the sign. So first thing we need to do is find the slope of this line. We always find the slope of a line by getting it in slope-intercept form, which reveals the slope. Alright, so we need to get the x on the opposite side of y here, so that 7y equals negative 3x minus 9. I just subtracted 3x from both sides. Then we need to divide by 7, divide everything by 7. And that gives us y equals negative 3/7 x minus 9 over 7. Okay, we don't care anything about this y-intercept here. We only wanted the slope, and that would be negative 3/7. Okay, remember, we want to be perpendicular to this line, so we need an opposite reciprocal. Okay, so right now we have negative 3/7. The perpendicular slope to that would flip this and change that sign. So our slope, our m, is equal to positive 7/3. Okay? So now we've basically got this problem done. We have our slope. They gave us an x1 and a y1 here, so now we just fill it in. So it's y minus the y coordinate they gave us, which is 6, is equal to the slope that we found, 7/3, times the quantity x minus the x coordinate they gave us, so that would be x minus negative 1. X minus negative 1 is the same thing as x plus 1. Alright, so final answer, y minus 6 equals 7/3 times the quantity x plus 1, and that is in the correct form that they wanted, which is point slope. Okay, final answer there. Alright, let's move on to our last 3 examples. Alright, example 7. Find the equation of the line in intercept form. That's this form here. Most students aren't as familiar with this. X over a plus y over b equals 1, where x and y are the variables, and a is the x-intercept, b is the y-intercept. So we want to find it in that form. That passes through negative 5, 0 and has a y-intercept of 2. Okay, so we know that already we have the point negative 5, 0, so we already have our x-intercept given to us right here. Okay, this line would look something like this. We have a y-intercept of 2 right here, and we have an x-intercept, because anytime the y-coordinate is 0, that's an x-intercept, right? So we have a line that looks something like, it's not a very good line, but it looks something like this. Okay, so we already know that this a value is negative 5. We already have that down because this a value was our x-intercept. We also have the y-intercept, if you see that right here. That's just 2. Okay, so this really isn't going to be very difficult. All we're going to have to do now is write this as x over our x-intercept, negative 5, plus y over our y-intercept, 2, is equal to 1. And we are done. Okay, so pretty straightforward. They gave us the two intercepts, the y-intercept and the x-intercept, and that's all this form needs. So final answer, x over -5 plus y over 2 equals 1. Alright, example 8. Next to the last example. We're almost done. Example 8 says, find the equation of the line in slope-intercept form that has x-intercept -8 and y-intercept of 9. So when they give you an x-intercept, they're basically giving you a point. That's all it is. -8, 0 would be that point. And when they give you a y-intercept 9, they're giving you another point, 0, 9. Okay, so we already have the y-intercept. We want slope-intercept form. So now all that we need is the slope, because they gave us the y-intercept right here. So to find slope, remember that's just m equals y2 minus y1 over x2 minus x1. Alright, and they give us all of that. So here we have x1, y1, and x2, y2. Now we can just fill this in and we're done. So we have 9 minus 0 over 0 minus -8 becomes 0 plus 8. So our slope is 9/8, right? So we have this done. We have found our slope, 9/8, so it's y equals 9/8 x. And then it would be plus our y-intercept of 9, so 9/8 x plus 9. Final answer right there. There's more than one way to do this problem, but I just use the slope formula. Alright, so let's go on to the last example for linear regression, and then we'll be done with this video. Alright, on the last, this is actually for my pre-cal students, a problem out of the homework, but we didn't have an example for it, so I'm going to use this problem to talk about linear regression. So the problem says perform a linear regression on this data and show the equation of the best fit line along with the sketch of the line and scatter plot. Give the correlation coefficient. Alright, so remember the correlation coefficient, the closer the absolute value of that number is to 1, the better the line of best fit matches your regression there. Okay, so the way we do that, I've already put this in. We go stat and then enter, and that pulls up our list 1, list 2. So we're going to put our x values in list 1, which I've already done just to save time, and then we're going to put our y values in list 2. Alright, so we're just typing those in. You just type each one in and hit enter, and it'll move down to the next value. Arrow to the right to go to list 2, type them in, and that'll get all your values in there. After we do that, we're going to go stat again. Everything's going through the stat button for linear regression. So stat, we go over to calc, and we're going to choose option 4 for linear regression. So we hit 4. Okay, the newer operating system has this menu now. So X list, list 1, yes, that's what we wanted. Y list, list 2, yes, that's what we wanted. Frequency list, we'll skip that. In order to store the regression equation, we can actually have the calculator go ahead and take the linear regression equation, the line of best fit that it comes up with, and put that in our Y1 in our calculator, so that we can go ahead and graph that. So that makes it a little faster. So the way that we just need to get Y1 in here. There's more than one way to do it, but I'll show you one way. We're going to hit the vars key, the variables key right here. You click that, you right arrow to y vars for y variables. We want function, so we hit enter, and y1 is the first choice there. So we're going to hit enter there, and that's going to store that equation in y1 for us, and I'll show you that in a minute. Now hit enter, highlight calculate, hit enter again, and it runs the linear regression. So notice here it gives you the y equals ax plus b, where -1.5016 and so on is your slope of your regression. So we have a negative correlation. We can already tell that because we have a negative slope. Our y-intercept is 2.436, etc. And the r value is our correlation coefficient, and that's -0.98. So it's pretty close to 1. So that's an okay correlation coefficient. If you don't see the r squared and the r value here, then you can go to mode in your calculator, arrow down, and you want to find the stat diagnostics right here. If that's off, if off is highlighted, you need to move to on and hit enter and highlight that. That way you get the correlation coefficient there, okay? So run that again. All right, so since I stored the equation in y equals, it's already there for me in y1. So when I graph a standard window, you can see we have a negative slope and we had a positive y-intercept. So the equation is already in my y1 right here. It has all the decimal places in there. So as far as answering this equation or this question, we could just limit the number of decimal places here. We don't need that many, but it does already have that's the nice thing about copying it is it is as accurate as possible without you having to type in all those decimal places. The other part, it wanted the scatter plot. So we can just go up here, arrow up to plot 1, hit enter. That'll turn the scatter plot on, graph again, and that graphs the scatter plot of all these points along with the line of best fit. So I'm just going to copy this over here real quick. And so that would be the scatter plot approximate graph, and then the equation of the line, we'll just write that out here. We had, from our calculator, we had y equals negative 1.5016. We'll just call that enough x, and then our y-intercept was plus 2, approximately 2.436, and we'll call that good. So that answers that question. Alright, that's a wrap for this video. See you in the next video.